Hello and welcome to Education at SSBJ online video tutorials. Let us have a quick glance on general instructions of your question paper for 2021, and then we'll pick up one sample question paper and try to understand some of the questions. I hope this will help us to revise the concepts which are already taught, which are already completed for class 9th. As you already know that the section A of the question paper contains from 1 to 20 either MCQs or very short answer question or assertion and reason type of questions. Right? Now this video we shall discuss regarding those questions which are from 1 to 20. Right? So physics, chemistry and biology all together you will find 20 questions, maybe almost 7, 6 and 7, or sometimes it may vary. So it's a sure shot for 7 marks if you consider only physics. So let us pick up some of the questions which are from physics part of this question paper. Please remember you have 36 questions in your question paper, and first question number 1 to 20 will be MCQs. You can pause this video and go through the remaining instructions. Now we'll go quickly for some questions picked up from a sample question paper. And here is the first question. So please remember that it is from, these question papers are from, questions are from question number 1 to question number 20, right? So that means they carry 1 mark each. So I'll read the question now. Which of the following figure represents uniform motion of a moving object correctly? So this answer demands understanding of what is uniform motion. Now you all have learnt the meaning of uniform motion. However, let me in short tell you what is uniform motion. If a body covers, right? If a body covers, or if any moving object covers, let me write body only. If a body covers equal distance in equal intervals of time, in equal interval of time, then that is what called uniform motion. Which means, suppose if a moving body covers, let's say we'll take a small example here, and it's moving straight, let us consider, and let me write below here the time 1 second, 2 seconds, just for our knowledge, 3 second, 4 second and so on. So when it comes here, 1 second starts and then another 1 second adds, it becomes 2 second, then third second adds 3 second. So equal intervals of time. So what is that interval of time? 1 second is the interval. I hope you understood here. So this is what the equal intervals of time. Now if the body covers equal distance, suppose from here to here, if it covers, let's say, a 5 meter distance, and then again from 2 second to 3 second if it covers another 5 meter distance, right, and then again another 5 meter distance, then we say that a body covers equal distance in equal intervals of time, right? So that is what called uniform motion. And if you calculate the speed of that, it becomes 5 meter per second. For every second it becomes 5 meter per second, because it covers 5 meter in 1 second, right? And therefore it is called uniform motion, right? Suppose if you plot a graph, okay, if you plot a graph, a distance versus time, distance, this is distance, I'll write a D in meters, distance versus time, and plot a graph here. Let's say you were here 1 kilometer stone, and here you will be 5 kilometer stone, right? And then you will be at 10 kilometer stone, because you have to cover 5 meter distance, and then you are at 15 kilometer stone. I hope you have understood. So every time 5 kilometer is increased. If you plot a graph here for every 1 second, 2 second, 3 second and 4 second, and then 5 kilometer, 10 kilometer and 15 kilometer, if you plot a graph, you will get a straight line like this, right? So which of the following figure represents a uniform motion? You should know what is uniform motion and quickly try to pick up option here. It carries only 1 mark. There is no time for you to think on. You have to understand much before and try to, and should able to understand the answer also. Okay, so the answer is option A. If this is option A, option B, option C and option D, A is the correct answer. So we'll go for the answer. You can see here, for uniform motion, the distance time graph is a straight line. Okay, but just don't memorize it. You have to understand why should it be straight line. We'll go for the next question. Shyam throws a heavy stone out of the boat. As a result, the boat moves in opposite direction. Why? Okay, so try to visualize this. The Shyam is here, okay, in the boat. Shyam is here in the boat, and so what he does is he throws a stone front, right? And then the boat will move in opposite direction. It always happens, right? When you climb onto a chair, right? So suppose this is a chair, right? And let's say this is a chair, and you are there on that, and you jump here, chair will go back, right? In the same way, you jump front here, the boat will go back, but here instead of you jumping front, you are throwing a heavy stone which is in the front direction, and because of that the boat will slightly go backward. Why? Okay, very simple. For every action, remember, for every action, and what is the action? This is the action. For every action there is equal and opposite reaction. And what is that? It is the Newton's third law. Okay, it's the Newton's third law of motion. Remember, because there is Newton's third law of gravitation also. So if there is an action, what is the reaction? This is the reaction. And they are in opposite direction, but they are in equal magnitude. If this is denoted as F, this will be minus F, right? So F is equal to minus F, and minus indicates the direction. So equal force, action as well as reaction, but direction is negative. So this is the reason. Second, in a tug of war, a rope does not move in any direction. Why? Because there is equal force on either side. Suppose if the tug of war is pulled in equal force on either side, it will not move because the resultant force here is 0. The total force which is acted here is 0. Right? So it's a simple question which is of 1 mark. So for the first question, it is third law of motion, and why the tug of war doesn't move, because they are equal and opposite. Forces are equal and opposite. Okay, if you show the force this way, this is the force. Okay, or if you show this is the direction of this force, and this will be the direction of this force. In whichever way you can take it. Right. The third question. Again 1 mark question, remember. How is gravitation different from gravity? Okay. Now, as far as gravitation is concerned, it's a force between any two objects. Let's say this is object A or object B. So there has to be some force as per the Newton's law of gravitation. Okay, we have studied this, and there is a force between any two objects. Okay, and that force is force of gravitation. But if one of the object is earth, if one of the object is earth, then if you take another object here, let's say our object is A is earth and B is some other object, so there is a force between A and B here also. This is also a force of gravitation, but in particular it is referred as gravity because it is related to earth. So if the force of gravitation as far as earth is concerned, it's referred as gravity. Okay, otherwise in general every force between two objects is called as force of gravitation. So gravitation is the force of attraction between any two objects, while gravity refers to the attraction between any body and the earth. We'll go for the next question. What is the work done against the gravity when the body is moved horizontally along the frictionless surface? Let's say there is a table, and the height of the table is, let's say, 1 meter from the, so height is 1 meter from the surface of the earth. Now you should remember, what do you mean by work done against gravity? So what is a work done then? Work done is, suppose if an object is made to move with some force, and if it covers a distance here, and if it comes, how much of displacement has taken place? Let's say S meters of displacement has taken place. Right? In this case, the work done is given by the formula F into S. This is for your information as far as 9th class is concerned, because we are taking an example of those situations where the body is moving in the direction of the force. I repeat, the body is moving in the direction of force, and then the equation becomes F into S. Okay, now this is what the work. And what do you mean by work done against the gravity? Against the gravity, suppose this is the earth, right? It's the earth, and there is a ball here, and you have picked this ball up. The ball has gone here. Now you have done the work against the gravity, because there is already a gravity, force of attraction from earth. Understood? So there is already a gravity. Against that gravity you have applied a force and taken this ball object. So every time when you lift an object from the surface of the earth, then you are doing a work against the gravity. Right? Now in this case, body is moved horizontally from here to here. Some work is done, but work is not done against the gravity. Why? There is no change in the distance. We have not lifted this above. Here the distance is 1 meter between surface of the earth and the ball. Here also there is a distance which is equal to 1 meter. So there is no change in the distance. And if you take a reference of the earth, the ball is at 1 meter distance above the earth itself. So therefore, work done against the gravity is 0. Whereas there is work done because it is moving front. Right? If you apply a force here, and that force has done some work. Right? So work done is there, but there is no work done against the gravity. So please try to understand, to have the work done against the gravity, body should be lifted from the surface of the earth, and there should be a change in distance. Okay, a student writing 3 hours science paper. Well, how much work is done by the student? So I said that force is applied and the body is moving here, then only work is done. If the body moves from one place to another place, let me repeat, if the body moves from one place to another place, either in the direction of the force or in different direction, and then the work is done. Whereas if a boy sits for writing an exam, okay, he will not move from his place. And that's why how much ever time he be there at one place, there is no work done because there is no displacement. So answer is very simple. So first case, there is no change in the height, so work done is 0, and there is no change in the displacement, so work done is 0. Right? Now one more question we'll pick up here. Okay. So this is the question which I wanted to tell you. This is assertion and reason question. Right? So you will find this instruction in your question paper. Right? And one assertion is given and the reason is given. Some choices are given. Now what does A mean? A means assertion. This is assertion. And what is R means? R means reason. Okay. And what is the assertion given here? If the distance between two bodies of mass m1 and m2 is increased by the factor 5, the gravitational force is reduced by 1/25. Right? Let me stick to this assertion now. What he says, let's say there is a body whose mass is m1 and another body whose mass is m2 and which is separated by the distance, let's say r. Right? Now the force of gravitation, force of attraction between this body is given by Newton's law of gravitation. And what is the Newton's law of gravitation? G into m1 into m2 by r square. Right? So this is the force. Now what he says, suppose if the distance is increased, if the distance is increased, suppose if you keep this m1 here and m2 far away, okay, and the distance has become 5r, right, increased by the factor of r, 5r. So what change will be there in the force? Right, so if it is 5r, then in place of r I have to take 5r, and so equation becomes 1 by 25, because this is 5 square, into g m1 m2 by r square. So earlier it was simply g m1 in m2 by r square. Now it has become 1 by 25 into g m1 into m2 by r square. So what is the change? It has reduced by this much, 1 by 25, right? It has reduced. When you increase the distance between them, force will reduce. If you change the distance 5 times, the force will reduce. Force will change by 1 by 25th. Okay, it reduces by 25 times. And it's a clear indication that more the distance here, more the distance, lesser is the attraction force between these two. Right? And how do you say mathematically? Force is inversely proportional to the square of the distance between them. Right? Let me write here. You see, if you can look at this, F is equal to G into M1 into M2 by R square. Understood? So force is inversely proportional to the square of the distance. Inversely means what? As the distance increases, force will reduce. Or if the distance reduces, force will increase. That is inverse proportion. And it is true. Okay. Now see. First read again. If the distance between two objects m1 and m2 is increased by the factor 5, the gravitation force is reduced by 1 by 25th. Okay, it's true. The gravitation force is inversely proportional to the distance between the two bodies. Okay, that's also true. Both are true. We have understood now. But please make a correction. Gravitation force will change by, is changed by 1 by 25. Okay, so in this case, which of the option is correct here? Look at this, both A and R are true. R is the correct explanation of the assertion. So this is the correct one. Remaining all three, if you can read this by pausing this video, you will find that these are wrong. I hope you have understood. In case if you want any query, please write in the comment box. We will continue with this sample paper again. Okay, thank you very much.